All right, good afternoon everybody and welcome to our Lync 2013 over the Wi-Fi network session. My name is Sasha Uratovic. I'm a senior program manager with our enterprise customer experience team. And I have a pleasure of David and Pascal today. You guys, do you want to introduce yourself?
Sure, thank you. Pascal Menezes, I'm also on Sasha's team as a principal program manager. I've been involved in the Wi-Fi side for a while on making Lync work over Wi-Fi.
Yep. And my name is David Frost, and I'm with Ixia. I'm an area manager, and I'm primarily responsible for the partnership between Ixia and Microsoft, and we work with them on many different Wi-Fi fronts.
All right, well, thanks so much, guys. So we have a really packed agenda for you today, a lot of content we would like to cover. So without any further ado, let me go through the session overview, what we would like to cover today. So to start with, we would like to level set with all of you in a room and basically tell you why do we care about Wi-Fi? Why do we talk about why it's important? We are also going to talk about different challenges when it comes to running real-time media over the Wi-Fi networks. And I'll introduce you to some common usage scenarios as we see them. Then I'm going to hand it over to Pascal, who is going to give you some guidance, deployment guidance for running Lync or real-time media, really, over the Wi-Fi networks. Pascal is also going to talk about our Microsoft multi-tier strategy, so different things that we are doing in the space, and also talk about some lessons that we have learned when deploying Aruba infrastructure in our MSIT environment. And then after that, David will take over and wrap the session up with a Wi-Fi network assessment. And hopefully at the end of a session, we'll have some time for the Q&A as well. So I've said I'll kind of level set with you and kind of give you some data points. Why do we believe this is really important that everybody should be paying attention to? So a couple of slides to start with coming from the Wi-Fi Alliance. And the first one is about the chipset shipments. The two really things that you should be probably taking away from this slide. The first one is the sheer volume of the chipsets that have been shipped by the end of 2013. You can see more than 2 billion actually. And the other one is that you can see that until kind of end of the 2013, for the most part, we were shipping, or the vendors have been shipping a dual band 11N. So 2.4 and 5 gigahertz chipsets, but that trend is now changing, and you can see more and more, and you will see more and more actually dual band 11N and 11AC chipsets being shipped out. The other one is, okay, so chipsets are kind of a base and a core building block. They are built into the devices at the end of the day. So this slide is really kind of a building on a previous slide and gives you an idea the number or the volume of the devices that are being shipped. And again, it's kind of nicely aligned with the previous slide in terms of a number. So 2 billion, again, devices shipped by the end of 2013. So we are talking about really a massive volume here. Now, couple that with some trends that we are seeing. So first of all, we are seeing our users, our customers, demanding more and more of the Wi-Fi networks. Essentially, they are seeing and they want from Wi-Fi networks what they're experiencing on the wired networks. They want that on the enterprise, in the enterprise environment. They want that in a public hotspots. They want it at home. We are also witnessing, I mean, you've heard that, I bet, number of times in this conference already, BOID. So people are customers, users are actually bringing their own devices. And the expectation is that, hey, they gave me this enterprise, I don't know, they gave me a laptop, they gave me a phone, but I would like to actually bring my iPhone, I would like to bring my iPad. And my expectation is that the same experience I'm having on enterprise-grade devices, I will have exactly the same experience on my devices as well. At the same time, pretty much everything that we are buying today is Wi-Fi enabled. You are probably witnessing, especially in a mobile space, for the most part, actually, Wi-Fi is the only option. You don't have an option on your phones, for example, to plug it into the wired, into the wire, or same goes for the tablets. So more and more actually Wi-Fi. Customers are also expecting that the real-time media, so audio and video, works really, really well over the Wi-Fi. So going back, I don't know, 10 years ago, we all started maybe with mail, with the browsing internet, and so on and so forth. But the trends in the last good couple of years, even probably more, is that the expectation is that not only a data itself, but a real-time data will work equally well. And then one additional thing, I mean, maybe not in all of the parts of the world, but the expectation is that the Wi-Fi will bring a reduction in the cost. So instead actually of paying the minutes for their cellular networks, they're offloading the data onto the Wi-Fi. So what are the challenges? So first of all, speaking of the challenges, there are three different scenarios as we see them when it comes to running a Lync 2013 over the Wi-Fi. First one is the data over the Wi-Fi. And what we mean by that is that you have your mobile devices, phone, tablets, laptops of a kind. And what you do is you really kind of run basic non-real-time media modalities. So that's your IM, that's your presence, that's web conferencing, and so forth and so on. So that's one thing. Then on the top of that, you put real-time media fixed. And what we mean by that is it's a very similar experience as with the first one, except you are adding some real-time media into the mix, so voice or video. But the assumption is that you are stationary while you're doing that. So you are actually sitting at your desk, you are maybe sitting in a conference room, you're sitting at home, you are stationary while you're conducting your call. And then the last one is a mobile, which is kind of a very similar to the previous one, but with additional twist. And it goes like, it's not only that you would do a real-time media, but also you would do that while you are moving. So you maybe start a call, you conduct the call, and then you end the call when you're moving from point A to point B in maybe your office. And the expectation is that would work just fine. So let me say a few words about characteristics of the real-time media. So to start with, I would like to make a differentiation between streaming and the real-time media. And the real-time media is really what is our focus for the remainder of the session. Streaming is just kind of a comparison to real-time media. So streaming is you're all probably familiar, or you have all experienced streaming in your life, whether actually by browsing your YouTube on your PC, maybe a Netflix. And the idea is you kind of click on a YouTube movie. You would see maybe a spinning donut where it would kind of load percentage, or you would see something like the video would start in 5 or 10 seconds, and then when eventually it starts, it would be pretty much smooth experience. And the reason for that is because on the receiving side, there is a large buffer that is constantly receiving the traffic, and is just smoothing out all of these network impediments. Well, that's streaming. Unfortunately, we can't do that for the real-time media. There is still some buffering that is definitely coming into the play, but nothing like 5 or 10 seconds as you would find in a streaming situation. And because of that, real-time media is much, much more sensitive to these network impediments. And really, there are three things that we are talking about typically. One is jitter, another one is delay or latency, and the third one is the packet loss. And we are going to talk about these more as we go through the presentation. So if there are any problems in any of these three typically network impairments, our human ear would sense that. We would hear that. So there are some kind of data points here. So our ear is tuned to if we experience, or if the latency from the sender to the receiver is more than typically 250 milliseconds one way, you would already hear that. You don't want that, by the way, necessarily. You would like definitely this number to be lower, but I'm talking about here the kind of the breaking point where the experience would start to becoming really, really bad. Bursty jitter and a packet loss are definitely additional two things to think about. Our Lync codecs that we have in our products, they are very adaptive. They can actually smooth the things out. They can heal the media as it comes along. But there is a certain point where actually we can't do that anymore. So we can recover some things, but there are certain things that we simply cannot cope with. A good example is, for example, a packet loss. If you have a packet loss every once in a while, that could be okay, and we can actually heal that, and you would not notice that. But if you have a sequential actually packet loss, so you lose the packets in a duration of, I don't know, a couple of milliseconds or something like that, you would hear that. So all of that, actually, all of these glitches are very disruptive for us and ultimately lead to the poor user experience. So what do we consider a good network traffic? So you can see on the slide, to start with, a consistent flow of data packets. So we definitely would like a packet as it goes from point A to point B to be consistent without any really loss or delay or things like that. Low delay, jitter, and a packet loss are definitely bad things. So that's something that is not good for the real-time media. It's okay for the normal data, for your mail, for your browsing. But as we go beyond a certain threshold that you're going to see in a slide or so, the thing actually would start to go south. It wouldn't be actually good. Random loss can be compensated. I've mentioned that already. Sequential loss, especially for example, packet loss, is definitely not a good thing. And then the last point is that as we find more and more demanding applications, so think about, for example, HD video, bandwidth is becoming definitely more and more of an issue. So I've mentioned to give you some numbers, that I'll give you some numbers. So these are, take the whole slide or the numbers of this slide as a guidance, and there are really, in a different maybe literature, you would find slightly different numbers, but they are all kind of in the same ballpark. So when it comes to the bandwidth requirements, you can see that as far as the audio goes, it depends on things like audio codecs. It depends on a sampling. You would find that the traffic or audio traffic would be in a range of 50 to 220 kilobits per second. For the video, it's a bit more, 250 to 4 megabits, and it very much depends on like if you go full screen, if you have a round table in a room. So that's why there is a kind of a bit wider range here. When it comes to the jitter, desired jitter is less than 20 milliseconds. End-to-end latency, on one of the previous slides, I've told you kind of a 250. Here I'm telling you, you really would like to go beyond 100 milliseconds one way. Acceptable is still acceptable is around 200. And now the last point here is it depends on the geography, obviously. I mean, it's just a physics. So if you have from east to west coast, you would typically expect probably this latency to be lower than if you are going from North America to Australia, maybe. And there are certain things that you just kind of can't avoid really in situations like that. Packet loss, we would like it to be 0, and especially, for example, on your wired network, it should be 0. There is really no reasons to be anything more than 0. On a wireless, it's a bit different story. So acceptable is still kind of below 2%. And the other important thing is 3 consecutive lost packets. Depending on kind of a packetization, let's say 60 milliseconds or something like that, you would like to be below that because at that point we can still heal the incoming traffic. If it's anything beyond that, you would notice it. UDP versus TCP is another one. So you know probably that our signaling runs over the TCP. Our media could run over the TCP or UDP. We want UDP. We definitely would like UDP. TCP is okay, but if there is a need to retransmit, I mean, with the TCP, it's just not really feasible. So for all of these reasons, really, the recommendation is UDP, and try to go with that. And again, this is obviously, I'm talking about real-time media for the Lync specifically. Okay, so let's kind of talk about specifically to the Wi-Fi. What are the issues that we are seeing people are running into when running not just Lync, but any real-time media over the Wi-Fi? So one is handover performance. So what do we mean by that? So imagine a situation you have 2 access points, left and right, and you have a client that is attached to one of those access points. And then as the user is actually walking from one side of a building to another side of a building, he should at one point be actually handed over to the other access point. right? And this handover performance could be a tricky. What we are finding is two really different issues here. We are finding sticky clients, and we are finding clients that are doing a ping pong. What do we mean by sticky client? Well, it means that a client is still associated with the first access point for way too longer than it should be. So the signal is really degrading really fast, and it's already really bad, which again could be okay for the normal data, for your mail or for your browsing, but definitely not good for the real-time media. The second thing is this ping-ponging effect. So essentially, it means that the client goes from one AP to another AP too frequently, and we don't want that. So that's one thing. The other one is off-channel scanning. So let's take a very simple example. In 2.4 gigahertz, typically, you would find 3 channels being in use because they are not overlapping, 1, 6, and 11. So let's assume that the client is talking over the channel 6. What the client would do, it would talk, it would kind of do, when you do audio or video call, it would go over the channel, but also what the clients are doing periodically, they go off the channel, so step off the channel, go to channel 11, listen for anything that's happening on that channel for other APs maybe, go back, and then go back to the channel 1. And if that's actually stepping over or stepping out of the channel that is being actively used for the conversation, that could be a problematic. So if you kind of step for the longer period of time, you wouldn't be able to actually send the packets or receive the packets, and obviously that's not good. So that's off-channel scanning in a nutshell. Rate adoption and transmission rate retries. So this is as the signal actually signal goes down, RF signal goes down. So for example, you are getting away more and more from the access point. You are walking away from the access point. What the clients will do, they will actually reduce the transmission rate. And there are issues. There are definitely issues associated with that. What we are finding also that some of these existing rate adoption algorithms are not really well suited for the real-time media. Also the other one is transmission retries. Again, for the real-time media itself, you don't want to have a lot of retries because, again, if you jam the RF radio frequency, it's again, somebody else is using the channel. It means that the real-time media cannot actually be leveraging it. So that's not good. Media admission control, this is very similar to, for those of you that are familiar with the CAC in Lync, call admission control, very similar concept. So we really need a mechanism to prevent the oversubscription of the access points. And there are a number of different ways actually how we can achieve that. You can see it's load balancing. It's steering a clients away from the congested access points. So if one access point is too busy, the controller can actually move the client to a non-congested access point. And so there are a number of actually different mechanisms that the vendors are using in order to avoid this oversubscription. And the last point, I think it's quite important as well, because again, it's not maybe so obvious. Once again, there is the data, there is your email, there is your browsing, or in a Lync world, it's IM presence and maybe a conferencing, but then there is a real-time media as well. For the data, typically signal-to-noise ratio and a signal itself could be lower than for the real-time media. Real-time media demands more. So you can see the numbers here. Signal-to-noise ratio, 25 decibels for the data, and we need definitely better for the real-time media, 40. And for the signal itself, it's minus 90 and minus 65. Let me talk about and say a few things about BOID. Again, nothing probably new to most of you guys. More and more, we are witnessing people actually bringing those devices into the enterprise environment. Now, the challenge with that, and Pascal is going to talk probably when he starts with his part, the challenge with that is that what we are finding is that these devices, BOID devices, they have a hardware that is simply not enterprise grade, which is kind of understandable. Maybe it's cheaper. Enterprise grade hardware is definitely more complex and more expensive. But then the expectation is, regardless, that that hardware would work well enough in your corporate environment or enterprise deployment as well. Unfortunately, for various reasons, some hardware reasons, some drivers reasons, that is just not a reality. So what you would find is that people are coming with their devices trying to do an audio-video call, and they're having a poor performance, or they're having a poor experience. So on one hand, you have frustrated users that are expecting more, that are expecting everything that they can see and find on their enterprise-grade devices. They're not finding that. And at the same time, you have IT departments that have to actually cope with such users and possibly make some tweaks in the enterprise deployment to accommodate these devices. And then what happens, I mean, this is something that has been going on for a couple of years, even more. The recommendation from the IT is don't do wireless. If you use BYD, don't do wireless. Go to the cellular or go to the wired if you have capabilities of doing that. So net, not good. So let me say a few words about common usage scenarios. And this kind of goes back to what I have shown you at the beginning. So you have data, you have fixed, you have mobile. So starting with enterprise fixed, it's kind of a small story. You have a couple of people, John and Diana, in a conference room. They're using their laptops. They're on a Wi-Fi network, and they are in a conference call. They start audio. Eventually, they start video, and then kind of a whiteboarding as well. And the expectation is that throughout all of that, they would have a great audio. They would see everybody in a panoramic view, so all the tiles of all the participants. And eventually the call would be successfully completed. So that's kind of an enterprise fix. The other one is mobile. So mentioned that already. You have Brian. Brian actually starts the call, takes the call on a smartphone, moves away from his desk because he remembers he has a meeting in a short while, moves away from his office to another side of the building, and when he comes to the destination, call is over, and he can actually step into the meeting. And obviously, the expectation is that a voice quality would be without any glitches, so perfect. Home, or a small office, home office environment. So this is Lisa. Lisa is working from home mom, and on a typical day, so she kind of joins audio and video call to discuss some business proposals with her partners. And then at the same time, as it happens, she has a daughter and a son. They're actually doing something as well. And they're leveraging a home wireless network. So son is maybe doing some audio and video on maybe Skype. And the daughter is actually watching her favorite movies on a television streaming over the Wi-Fi network. And the last but not least, it's a hotspot situation. So you have John, who is in a local shop, and he receives an email. Sees the email. It's kind of a crisis that he needs to attend. There is a link. There is a link to dial the number. So he dials the number. He conducts the call using the VoIP, over the VoIP, and completes the call. And after that, happily can actually enjoy his coffee. So four scenarios, different scenarios that Pascal is not going to build on and walk us through a deployment guidance for these scenarios.
Okay, thank you, Sasha. So how many people here are really familiar with Wi-Fi, like a Wi-Fi expert? 1, 2 hands. How many people are deployed UC over Wi-Fi, Lync over Wi-Fi? Interesting. Love to hear your experience. So I think we'll go through some deployment guidance as to what we suggest. We'll also go through some, Sasha will come back, talk about the QoS, how to set up QoS correctly. And then finally, we'll talk about some lessons learned out of 2 years of dog fooding, the things we uncovered. So hopefully, maybe match some of your stories, so your war stories here. Let me start here. So I'm going to cover the enterprise side, the home, obviously, and the hotspot. I'm going to focus more on the enterprise. I'll cover a little bit of home and the hotspots, but I think most of you guys are how many people here are enterprise customers, end user customers? Okay, quite a lot. Good. So please, I want to make this interactive, so if you have questions, please feel free to ask them. So basically, enterprise design considerations. I mean, can your network handle a load? So what we found in MSIT is that basically Microsoft's IT is where we did a lot of the dog food. We were seeing that, with UC, we started with, just the handset and our desktop. But now with mobile tablets and, smartphones coming in, we have UC smartphones. soft phones coming in. People on average are about 2.5, I would say about 3 devices now to a user. So that's going to add load. And so you now have your smartphone, your tablet, which are both Wi-Fi, and then you obviously have your wired desk and so on. So that's adding load to how many devices have to be supported on the AP side. So also, like Sasha said, are you really just going to do IM and presence, or are you really going to start doing voice and video on it, and more likely you can do voice and video on it? So real-time media is going to be very important, and how do you support that? So we'll cover that. The other thing is ubiquitous coverage. Unlike where you set up an AP in your conference rooms and in your reception areas, if you want to run voice and video and you want to kind of do it where users have proper coverage, you don't want to have blackouts or brownouts. So it's ubiquitous coverage, and then how to get that set correctly so they don't interfere. All that's planning stuff. And then finally, is your network ready for BYOD? BYOD is a huge challenge. Unless you're controlling, I don't think any of you control your devices coming in from your users. BYOD is really what's happening, and so how do you manage that is really a tough problem. And we'll talk about a program we're putting in place and some standardization to try to address this. This is probably one of the biggest issues. How many, show of hands, are you seeing a lot of issues with BYOD coming into your enterprise, and how are you managing it for Wi-Fi? Oh, just a few. Okay, interesting. Show of hands, how many people are having issues with running Lync over Wi-Fi? Oh, good. Okay, it's a good session then. Okay, let's see if we can answer that. Okay. And then finally, QoS. Can't underestimate. For a consumer side, you can get away with having no QoS. Obviously, Skype doesn't use QoS. And that's okay because, in the consumer side, they're tolerant. They're getting free services most part. But in the enterprise, you see very, very, very strict about having that experience. It's got to be the experience of basically that call is just like my old phone call, 5 nines available, high quality voice, and they expect it. And so how do you deliver that? Quality of service is a necessity of the underlying fabric to make that happen. Without it end to end, you will have problems. And I've actually witnessed this. We can go days where things run great, and then all of a sudden you get these congestions, or who knows, some event happens, and all of a sudden it sounds horrible, and you can't understand why. And then when you look into it, you'll find that some access router was remarking, or some, policy was incorrectly set for the mediation server, or something like that. It's very common to see this all across QoS policies. So basically, the deployment guidance for enterprise planning is let me see if I can see this here. Wi-Fi only. Obviously wired Wi-Fi. So determining what's the right devices to use, obviously, you want to phase out some of the legacy devices. But in reality, you're going to have BYOD, so you're going to have to support almost everything. Density, I talked about density. I talked about, just not the conference rooms. It's going to have to be deployed everywhere. The other thing is mobile support. You're probably going to want to run your own SSID for mobile versus regular, for the mobile devices. You want to set your TIM value differently to get power saving, but that will affect, when you set that, it affects other things. But the bottom line is that you want to have power save. So when you have a mobile SSID, you have a regular SSID for the tablets, which are sometimes plugged in. The mobile SSIDs, you're going to walk around, because this is becoming a common scenario. You're loading Lync up on your smartphone, and you're taking calls, and you're moving around. And I think, Sasha, you talked about the idea of mobility. This is going to become more and more common as a use case. So, the deployment guidance is basically, we have a qualification program, which I'll talk about. We recommend on Lync 2013 now. 2010, we don't really say we support Wi-Fi, though you can do it and you'll get away with it. Officially, we say it's a best effort thing. We don't really support it. On 2013, we do officially support Wi-Fi. And one of the ways we did that was we actually did a lot of testing on it. And we did it specifically on 11N, not on 11ABG. So therefore, we're saying that if you are going to deploy Lync over Wi-Fi, you really should be supporting 11N or 11AC is a newer version come out. for a gigabit. So that's really a must. If you have level older stuff, we're recommending. We're not telling you have to. We're recommending that you support 11N. We're also recommending that you buy enterprise grade Wi-Fi gear, and we have a qualification program we'll talk about that tests this enterprise grade gear to make sure it's doing all the right things. We don't expect you to go and buy something of a home kind of AP, and I won't put names, and bring that into your enterprise and try to deploy that, because you will not have good success. So enterprise grade APs are very important, as you probably know this already. There's a thing called the Wi-Fi Alliance, has this thing called Voice Enterprise. Anybody heard of Voice Enterprise? Voice Enterprise was a standard that's come out that was supposed to handle voice over IP, over Wi-Fi, and do a great job. Unfortunately, what's happened was it got poorly implemented, and it really just talked about a pix pro forma about what protocols to support, 11K, 11V, WMM, and all these other things. But it didn't really measure anything, and it didn't support video. Video was not a requirement, so there was no performance criteria to measure that on the certification program. And as a result, it's just not showing up in many devices. Most AP vendors will support Voice Enterprise, but you will find many devices don't support it. So we'll talk about a newer version of that coming out, and I don't know how much we can say, Sasha, but I think you got permission, but I'll cover a little bit about some of that from what we can say. Obviously, implement WPA2. You guys know the security. There's nothing new there. So the key caching is really important when you want to do any kind of mobility. So OKC is pretty well in every version. I think it means part came in as 11i, I believe, was OKC, opportunistic key caching. It's in pretty well every device, every AP. So OKC is a great way of doing, and key caching is really want to roam. If you don't have that, then it takes up to a second or more to go to disassociate and renegotiate the keys and all that. So you have to, you want that key caching. So it's there. 11R is the newer version of that, and that's what's implemented in Voice Enterprise. And so 11R is not fully supported all over the place. So trying to get 11R support, and it sometimes takes a stack change. And so that's why Voice Enterprise has had some problems in getting out. So I'm getting a little details here. Configure load balancing for APs. We'll get into more details about that. And then the WMM planning, cost planning, we'll get into a lot of details. Sasha is going to get really in detail about how to do that right. The roaming part, let's see. So basically, deploying dual band APs are really important, because you want to be able to really push as much of your clients that have 5 gig capability on the uniband to push them off on the 5 gig, because the 5 gig is more noise free, less interference, however has very short distances. But given that if you've got the right AP deployments or AP spacing, probably like every 60 feet apart, depending on what your wall design, open space wall, it's a better spectrum to get onto. You'll get less problems. But obviously in the home, it's a different issue. But in the enterprise, it's great. So you want to be able to do what we call band steering. And a lot of the APs have the ability to see that it's got support 2.4 and 5 and push that client on the 5 gigahertz instead of staying on the 2.4. You guys all know about the 2.4 gigahertz band. It's only got 3 real, 1, 6, and 11 that everybody uses. And that's really the capacity of the channels that you can really get out of. So the reuse is not as good as the 5 gigahertz. So the radio management is real important. Make sure you buy AP gear that does radio management for both power and RF, so that it's adjusting all the time the power requirements for the AP and the right channels it's being used. And it's all being done by this resource management system sitting somewhere in some centralized spot. And this is very important. Most of the vendors are doing that today, support that. It's part of the enterprise grade deployment. Let's see, capacity planning. I think we talked about this a little bit. Deploy densities. Very, very, very key point. If you don't take away anything else but this one point, running data over Wi-Fi is radically different than running voice and video over Wi-Fi for probably the most important reason, but many other reasons, is that the signal, the received strength, if you get minus 90 dBm, you'll run data fine. If you try to run voice on that, you will get a horrible experience, okay? Because you'll get a lot of retransmissions start happening, and it just will not be a very pleasant experience. And same with signal and noise ratios. You know, if you could go down to 25 dB for data, it'll run fine, but you need about 40 dB of headroom to get voice and video to run right. And it's all about, you know, try to avoid the retransmissions, avoid the rate adaptions that happen when you get these poor signal strengths happen. They go into rate adaptation algorithms to increase the power levels. And so this is the key takeaway, and I think Sasha gave you some great numbers on there. You want to really be careful of that. So AP deployments, where you place your APs to make sure you match those power, the signal and noise ratios and receive strengths are critically important. And that's going to dictate, you know, a good part of what your user experience is going to be, minus the BYOD side, which is going to have a plague of driver problems, which I'll cover. And there's not much we can do right now until we solve this. And we'll talk about how to solve some of that. Let's see what else I want to cover here. I think that's, I covered most of those. So large conference rooms, obviously big problem, you know, but having multiple APs, load balancing is what you want to do. QoS, turning on QoS, and prioritization. Our SDN APIs, everybody heard about this SDN API? Anybody? Just a few, actually surprised. There's 4 sessions being going on, or actually 4 tracks on this SDN API. There's one this morning on a great one about using the SDN API with Maruba to do some very cool stuff around this area. And so if you can, I think there's another one tomorrow. If you can catch that one, I think it'll be very enlightening of how we try to solve some of these issues using the SDN API. Let's see, for enterprise physical recommendations, cell deployment. So what you'll find is open walls. We had this really cool experience. In Microsoft, a lot of our offices we got our own actual office. I mean, everybody has their own office with actual walls, not cubicles. And so the design of that is radically different, and we have like 100 buildings like that. And you walk outside your office, and every 60 feet you'll see an AP, and that's really great. And it covers really well, and the walls block off, and so you got this great coverage. But what happens is when you try to do the same thing in the same density of APs, and you try to do it in an open space, you'll get the cellular overlay you put in place, you'll get a bleed off from channel 1 over here, you might use 6 over here, and then all of a sudden you'll get one showing back up way down over there, and it'll cause interference. And so you can't be that dense. And so open wall, what we call open wall concepts, are much different in deployment than closed walls that are, you know, offices like I talked about. So we learned a lot about that. We didn't realize it had such an impact. It had a huge impact. So we had to fix a lot of that stuff. What else I want to say? I think that's surveys. This is real important. Highly recommended that before, and you'll see David talk about this, before you deploy Lync, you really want to understand your environment you're dealing with. We talked about open wall, closed walls, where you place your APs, all that stuff. We talked about signal noise, all that kind of stuff. 11N, make sure you have the right technologies. 11N, by the way, has WMM by default, has to be in it if you buy 11N gear. WMM is the mobile multimedia, not Windows, but it's the mobile multimedia that ensures QoS, and we'll get more details. Sasha will talk about that. So this is really important. And the surveys, what they do is they actually make sure, like a pre-site survey, things are kind of documented of what that looks like so that you architect the right placements of APs and so on. And then finally, you want to then finally do after you've installed it is to actually get an assessment done to make sure that what you think was architecturally correct is architecturally correct. So again, we'll get David to talk about some of that. So also on the client recommendations. So the BYOD, I'll talk about some lessons learned, but real issues with BYOD. There are a lot of problems with device problems, and it's shocking to see how poor some of these qualities are, because you're getting anything from very high quality $2,000 laptops with the very 3x3s by 3 spatial streams that, or you'll get a 1 by 1 by 1. So, and they vary all over the place, and they'll have a huge impact. How you hold, where the antenna's placed, where you hold it to your body, it all has an impact with wireless. So this is a big issue. Mobility, we talked about that. Mobility itself, the ability with these BYOE devices to actually hand off if you're moving is all over the place. And in fact, it's probably one of the most busted scenarios there is, because what a lot of these devices do is they try to hold on to an AP, and we call them sticky APs. They try to stick to an AP, and even though there's another AP that's got a better quality, better signal, better everything, they won't jump to that because they just don't have that awareness that there's an AP. They don't scan at the right intervals. They don't do the proactiveness to know all the APs and when to let go, and they don't have that kind of intelligence. Most of them, not all of them, but most of them. And so that affects your ability to move while you're taking a phone call. What else? Real-time media optimization, certified NIC drivers. So we'll talk about what we're doing with some of these ideas of trying to certify these devices. Let's see, radio resource management. We tried to turn that on. We had some horrible experiences again with the drivers, and I'll cover that on some lessons learned. Home recommendations, obviously, we'd like you to buy 11N gear because 11N has WMM, and WMM is the QoS, so everything gets mapped. What you'll see is Lync, if deployed correctly out of the box, there's no QoS markings. If you use the SDN API, it'll automatically provision everything for you, but let's leave that one for now. So let's say then, if you're just using regular APs, turn on Lync, you got to turn on quality of service. Sasha will talk about how you turn on quality of service for Lync, and that will start marking diff-cert code points. And those diff-cert code points will get mapped into to the lower layer WMM tags, media tags, or these tags on the Wi-Fi. And there's 4 classes. And so the diff-cert code points will get marked into the voice class, the video class, and so on, the data class. And 11N ensures that that's done correctly, meaning that the classes and the way it's prioritized on the air is all done correctly. And it's mandatory if you have to be 11N certified. Again, like the enterprise, try to go to the 5 gigahertz. I don't like the 5 gigahertz at home because it doesn't have the distance. So you're going to have extenders. You have to have multiple APs. It's a lot more work if you go to 5 gigahertz, but it's much more cleaner because in the 2.4, guaranteed you're going to have problems, especially like Xbox with the wireless consoles, the Bluetooth consoles, a lot of Bluetooth devices, your microwaves going on, cordless phones, notorious, even though some of them have moved on to the uniband. So these are the things you kind of want to be noting. So, hotspot recommendations. Recommendations for hotspots. I don't know if anybody a hotspot provider here? I don't think so. But I mean, to be honest, if you're going to do a hotspot and you're in a hotspot and you're going to do public hotspots, you want to be using the enterprise grade kind of APs we talked about. I'll just leave it like that. So configuring QoS for your Lync deployment, I'll turn it back over to Sasha.
Okay. Thanks, Pascal. Okay, so I'll walk you through how to configure really QoS for the Lync. So I'll be focusing solely on Lync. I won't be talking about how you do that on, for example, Wi-Fi access points or controllers or any other network equipment. Actually, there was a very good session. I've seen actually a couple of very good sessions. So there was a session earlier today that Pascal already alluded to about SDN and Wi-Fi. So Aruba and co-presented by Microsoft. So I suggest and encourage you to see that because these guys covered actually some details on how to do that on a wireless access points on Aruba. So won't be focusing on that. Solely focus will be really on the Lync. And I will really, to kind of even more zero it down, I will be focusing on a server-side configuration and on a desktop-side configuration. But before actually I do that, there are really a couple of things that you need to know when it comes to the QoS and a Lync configuration. There are really 2 things in a nutshell. I mean, you would find a documentation on a TechNet, on a web, but in a nutshell, there are really 2 things that you have to worry about. One is a port configuration. Essentially, what you have to do is that when a mobile endpoint is sending a traffic, either a client or a server, you would like to say, hey, that traffic needs to be sent over these specific port ranges. And what you really would like to do, there are a couple of things. First of all, you would like to have a consistency across the board. So if you do a configuration, there is nothing actually that is forcing you to do that, but it's just one of the best practices. Really what you would like to do is to say, if I'm using X to Y port ranges on my server 1, I would like to do exactly the same on my server 2, and so on. Okay? So that's one thing. The second thing that you would like to do is you would like to avoid overlapping. You don't want these port ranges to overlap between audio, video, desktop sharing, for example. You would like to have non-overlap ports. And you will see actually that by default, that's unfortunately not the case, so you would have to make some changes. And the last but not least, so you do that on a server side, you have to do it on a client side. Now on the server side, we are requiring much more those ports to really support the load. On a client side, it's not so much. But the recommendation here is to use a subset on a client side when it comes to a configuration, use a subset of what you're configuring on a server side. So you can see an example here for example, if you're doing a server audio port range, you do a wider range, and then when you do it for the client audio port range, you use a subset from that wider port range. So that's one thing. You have to configure port ranges. And the second thing is, once you do that, you have to say, you have to really configure a quality of service. You have to configure a mechanism that when the packet is coming over those ports, you would like something to mark those packets appropriately. And this is really kind of a job of quality of service policy. Unfortunately, well, fortunately or unfortunately, you have that only on the latest version of the operating system. So you have that on Vista 7.8 and 2000 R2 and 2012 when it comes to on the server side. If you, for whatever reason, are still running Windows XP, hopefully not the case anymore, but just in case, if you are doing that, it's a bit different story. We are using Quos Package Scheduler. And there are really kind of two things that you can do with that. You can mark the packets for the control loads. This is a video or DSCP 34, or for the audio, which is DSCP 46. And even once you do that, actually, on the XP side, on the OS side, there is still something that you have to do. You can see this commandlet you have to execute on a server in order to enable Quos. So by default, Quos is disabled. You need to enable it. A few other words about some other clients. I won't be touching actually and drilling into these clients moving forward, so in a subsequent slide. So I might as well actually say a few words about them now. So one is Lync Phone Edition client. By default, they are marking audio traffic with a DSCP 40. However, you might know, you might have seen actually that one of the recommendations is to mark audio traffic with expedited forwarding, EF, which is the DSCP 46. So again, you can do that, and the way to do that is to execute this commandlet. Okay. On a Mac client, so Linux for Mac 2011, we are using two specific markings, CS5 for the audio and CS3 for the video. And as of now, there are no ways actually to change that. And on a mobile client side, they're actually using some hard-coded values, depending on mobile platform. Okay, so now actually going into some more specifics. So first, I'm going to cover how to deal with a server side. More specifically, there are really your MCUs or conferencing servers, there are application servers, and there is edge servers. And then I'm going to cover the client side or Lync desktop side. So starting with the server side and the port ranges, you kind of have to separate these two into two buckets. One is a conferencing and application, and then you deal with the edge separately. So what you want to do is, I've kind of, in the first slide of this section, I have hinted there is some overlap. So what you want to do is you want to use this specific commandlet to change application sharing port. Because by default, as you can see from this table, you can see there is an overlap between application sharing port and audio port. So that's something that we generally are discouraging and don't want people to do. So in order to change that, the commandlet is here. So once you do that, you can actually move to the edge side. So you're done with the conferencing and the applications. You move to the edge. The only thing really you want to do on the edge side is you would like to define a port range. Really nothing much. Now, once you do all of that, what you end up with is really you have a default port value for the Lync 2013. Once you do the change per this commandlet, the table will look very, very similar, except obviously this last portion will be changed. And once you are happy with that, you move to the edge, and if you execute this second commandlet, then you would end up with recommended port values for the edge server. So that's you've done with the ports. So you essentially at this point you said, hey, for all these media on a service side, use these specific ports. Now we have to actually configure a quality of service, and there are really two things that you have to do. Again, you kind of split it again: application and a mediation server and edge. Very, very similar with a minor twist. Both are procedural-wise or process-wise. They are pretty much exactly the same, really. It's just the red thing in the tables, as you can see, this is the major difference, really. But in both cases, you use a group policy editor, and with a group policy editor, you're essentially creating these policies. And for each and every modality for audio, video, and application sharing, you have to create one of those policies. So you go to the group policy editor, computer configuration, window settings, policy-based clause. You would see a screenshot like this, and then you essentially say create new policy. Once you do that, it's a wizard-driven kind of a process, and in this wizard, you're essentially using the ports from, or the data from this first table. You do it first for the audio, then you do it for the video, and finally for the application sharing. Now, what you do for the application and mediation servers, a source port is important. However, on the edge side, the process is exactly the same, but what you want to do is you want to do a marking on internal interface of the edge server, and you would like to specify a destination port range. And that's the reason why you really can't copy and paste almost policies from application and mediation service to the edge. There is a process-wise, same. And actually, if you look at the ports, data is exactly the same, right? It's just the difference is in source ports versus destination port. So that's on the server side. Client side is very, very similar. It's almost identical, I would say, except it's a bit different commandlets that you would use. So if you execute get -cs conferencing configuration, you would see a default. And what I've kind of highlighted in red are the default values. And you can see that the client media port ranges are actually set to false. So enable is set to false. And you don't want that. You would like to enable, actually. So you would like to say, yes, I would like to do this segregation, port segregation. And also the other thing, as you can see, we are doing the overlapping. We are using same ports for the audio, video, application sharing, and a file transfer. So what you have to do, if you want to implement this, and as you've heard so far, definitely would like you to do so, you have to execute this set CS conferencing configuration. You have to change the enable, so you have to change the first to true. Say, yes, we would like to do that. And then essentially what you do, you use a different port for different modalities, audio, video, application sharing, and a file transfer. And you end up really, you are using values from the table above, from the table at the bottom of the slide. That's what you want to do. Once you do that, again, same as you have done on a server, you have to do it on a client as well. You have to use the quality of the service policy to create the policies. Procedure is exactly the same, really exactly the same. Couple of things I haven't mentioned. So I've said on a previous slide about creating the policies, about using the data from the table to create those policies. I actually haven't mentioned these GP updates for us. Essentially, if you would like the policy that you have created to take immediate effect, you would like to execute the GP update /force. And then there are some edge cases. So if you have either a multi-adapter machine or if you have a machine in a workgroup mode, in that case, you would like to do not use NLA equal 1. You can see the full path here as well. And that's actually applicable to the configuration on the server side as well. Okay, so Pascal is now going to cover our strategy all programs and MSIT.
Yeah, and I think we're running out of time here, so we got, what, 20 minutes?
Yeah.
So how many people here think deploying Quas is really hard here for Lync? 1, 2. Oh, how many people know and are doing this on their Wi-Fi infrastructure, deploying these Quas policies for Lync? Boy, there's a lot of customers in here that said they're doing Lync over Wi-Fi, and only a few hands that said you're actually doing the Quas policy. So you're actually running no Quas for?
We're actually looking at trying to get it established. We know we have some of the infrastructure that's not falling out compatible.
Yeah, so yeah, trust me, if you do not deploy Quas, and Sasha did a very, very, very great detailed job, and I know it's kind of very detailed and lengthy, but you've got to go through those steps to get Lync up with the right Quas policies. That will translate down into the WMM tags for Wi-Fi. And then, if you do have them on the WMM for Wi-Fi, that will only affect the upstream direction from the station to the AP. From the downstream, from the server coming through the infrastructure, hitting the AP, going to the station, it could get stripped off by the infrastructure or changed. You have to be careful of that, and you have to watch for that, and that's a very common problem that you need to be aware of. So even if you do all the right things on the Quas policy that Sasha talked about, you might get Quas really good on the upstream direction, but the downstream might not be coming in correctly because it got remarked or stripped from the wired infrastructure before it hit the AP or the controller. So warning about that. It's very common, seeing that all the time. There is a session, again, called SDN, Software-Defined Networking. We've been pioneering this with 3 different use cases, one on diagnostics, one on Quas, automating quality of service. I'm actually doing that at 4 o'clock today, if you want to try to attend that one. You'll see how a lot of this goes away, and there's one on for Wi-Fi, SDN for Wi-Fi, which a lot of this goes away too. All this it automates all of this. Very powerful concept. So hopefully this will be the old way, and the new way will be the SDN models that you can see in the show. And this is all shipping stuff that you can actually go and acquire, buy, and use. So let me continue on. We did, so in 2011, I pretty well had the program to go figure out how to make Wi-Fi work for Lync. And so it was quite the feat because it was a lot of work. So we came up with the idea of, let's start with the AP side. Let's get a qualification program in place to test the APs to do the right things to all of the deployment things I talked about. You know, do you support 11N? Do you have what, all the things I talked about. And also deployment practices. These guys have to, you'll see listed here, have to on their website to give you not only their test results, but how you deploy Lync over Wi-Fi. And if you don't, let me know, and I'll make sure that gets enforced. So it's a deployment guidance practice that they tell you how the knobs, what to change to make sure Lync runs over Wi-Fi correctly, to all the things we talked about, including where to put the APs, signal and noise, all the things we talked about. So this AP qualification program was done by Ixia. It's about a 200-page document, test document, a massive amount of test cases. It tests 3 major categories: Lync over Wi-Fi for data only. Obviously, that's simple. Lync over Wi-Fi for real-time media fixed. The scenarios we talked about fixed. And then mobile. Lync over Wi-Fi for real-time media while you're mobile. And those 3 categories are tested extensively. It's a 2-week test, David? 2-week test. 200-page test document, very extensive. Proud to say, after about a year and a half of that program, working about 9 months into it, and now about another 9 months actually of testing, we have all these partners qualified. I like to say, including Cisco. So it's been quite a feat. It's great. You should be able to now go onto this UCOIP website. If you actually search Lync UCOIP, you go to networking tab, pull that down, you'll click on that link, you'll get to their web page, and there you'll see the test results, deployment guidance practices, what knobs to turn on and everything. So that was the idea of this. I like to say that we're about to announce a device equivalent for the device side. Now, that's going to be a lot harder because there's a lot of devices. But the idea would be to, for example, if you had a chipset and you had, I don't want to mention names, so I'll just mention company ABC that has major laptops, right, or tablets. the idea is if they buy an Intel chipset or Broadcom chipset and they use that chipset with the same kind of drivers, then all the models that use that should be able to qualify and be qualified for one test pass of this. And the idea what we'll do is we'll actually, like the AP side, we'll test that device to do the real-time things, so that they don't go off channel and they go off for a second or 2 seconds and break the audio video while they're doing off-channel scanning, so that they do the proper mobility and they hand off and they're not sticky. They don't do things like, and this is very common actually, I've seen this many times over as part of the device issues. They actually go ahead and while they're plugged in battery, they go at a higher power for Wi-Fi, and when you unplug them and they go on battery mode, they go on a lower power. Great for data, does not work great for voice and video. Very common problem happening. So we'll test for that. We test for many other things, including noise, how it affects it. It's a really great program. It's going to be announced. Dave will talk more about that, I think. So it's about to be announced in the next weeks to a month. So each vendor will publish their test results, just like the AP side, and you'll see exactly what's broken, the drivers that we tested, what version of driver and all that. So it'll really help on the BYOD side to know that if you bought ABC devices coming in, obviously there's some really big tablet names out there. So you can actually go and see that and see how well they're working. So hopefully that will help a lot. All of this is really to get to a pre-standard. Those two certifications are really pre-standard certifications. What we really want to get to is standardizing multimedia over Wi-Fi. And while I don't think I can disclose exactly what we're doing here from the WFA point of view, we can say there's no single standard or certification encompasses the need of real-time media yet. Microsoft is championing efforts in the Wi-Fi Alliance. I'm actually, I can't even say that, but let's just say that we are driving hard to make this a reality. What you see in the device and the AP qualification program will be a WFA standard. So that will be the official certification program that we want to get to. That's what we're trying to drive to. The priorities are improving Wi-Fi for roaming and application performance, obviously. Address the needs for enterprise, home, and public venues for all those use cases that Sasha went through. And really, the name of the game is to get full ubiquity, full compliance, a lot of participation from the AP vendors, which are a lot easier, but the device vendors, the plethora of devices from, I don't know how many device types there are, maybe thousands, 10,000 types, will just automatically embrace this certification standard, and we'll test for performance. We'll test not just for protocol compliance, we'll test for many things, just like the device and the AP side test for. So that's what we're striving for. The net result, you guys as end users, operators, system integrators of ours, makes your life a lot easier. So lessons learned, and I think I don't want to take Dave's thunder too much. So we actually spent 2 years in these buildings. Building 3031 was closed office spaces. We started there. I went to, got $120,000 to upgrade the buildings, put 11N in. We learned a ton of stuff. And then we went and we also moved into these open space buildings in the Skype side that are just full, just like the Facebook model, which everybody's just desks in one big open hall. And that was a radically different design, so we learned a ton on that. I went through a lot of that stuff. The bottom line is that using all the things we talked about, all the guidance we talked about, and using qualified AP vendors stuff, we got it down from 7% bad calls down to 3%. So that was a great accomplishment. Obviously, you're never going to get to zero. It's just the nature of Wi-Fi. But it was a great experience for us. A lot of lessons learned around the device side really burnt us a lot. We were getting a lot of problems where drivers were doing the funkiest stuff, and we were chasing those things down. I had to get new driver updates, and we had to tell our users that, and it just was a plethora of those kind of things happening, and that's why we're trying to get a device program in place. What else do I want to say? Lessons learned. Density, I talked about performance, about open space versus closed space. Load balancing, I talked about the BYOD client issues. You get everything from very expensive devices to very cheap devices. And we talked about mobility of the client roaming. So I think with that, I'd like to bring up David. And David is our test house for the AP and the device side. But the interesting thing about Ixia, and you're going to see, is they are the #1 test and measurement vendor out there. And they've now gone into the whole testing with us, and they're really a great, great partner, and I can't say great things about them.
How about now? Is that a little better? Okay. All right, well, thank you again, Pascal. Appreciate the introduction. So Ixia has been a partner with Microsoft on a few different fronts. Okay, primarily, as of late, Wi-Fi, especially when we talk about Lync and BYOD and Lync deployments. What we are trying to do, and what we have been able to do, is actually leverage our test house program and those testing scenarios for APs and soon clients, and really bring that out into the field for network readiness testing. Let's see here. So in terms of why Wi-Fi matters for Lync, obviously a lot of this was covered, and I won't go into it too much more aside from that. But different caveats, different permutations when you're trying to deploy Lync over Wi-Fi, mobility, BYOD really introduces a lot of different types of scenarios, lots of different types of issues. And really what you want to do is assess and benchmark your network environment before going ahead and deploying Lync. So in terms of why Wi-Fi is typically a bottleneck, it's definitely designed for signal strength and not the client experience at scale. And we've seen this to be pretty dramatic issues out in the field. And really, Wi-Fi network instability over time, peak hours, different usage models, you have slow times, et cetera. And also poor application coverage due to installation and client device behaviors. So a lot of times, the IT customers know that there are Wi-Fi issues, but not really how to identify, fix, and validate them, and sometimes really how to optimize it, okay? Especially with the nature of Wi-Fi, definitely not the same as wireline or Ethernet. And as more and more folks now come into the office, you don't really have as much plugging into a LAN drop. Now everything is mobile. It's going to be over Wi-Fi, so it's becoming more and more prevalent. And some of the behavior differences you'll see here are, for example, full wire rate supported by wireline, but not on Wi-Fi. And PHY data speeds, as well as client integration, mobility, and installation. What you're seeing is just different behavior characteristics of the different network types that you're going to encounter and why they have a different type of impact on Wi-Fi, okay? So overall, Wi-Fi networks rarely fail outright. Most of the time they are operational, you'll have coverage, but they're not really dialed in or optimized for UC deployments, okay? Whether it's under-designed for the intended Lync load, one client caveat, slow behavior is really impacting the infrastructure for others. And also sometimes it's just a matter of different client device permutations. Really sessions deteriorate due to distance, roaming scenarios, sticky, and different AP and client behaviors that Pascal and Sasha discussed earlier. So what Ixia does is we offer an assessment type baselining service model, okay? And some of the differences that you're going to see here is an example of a couple types of heat maps. One is coverage, right? At first glance, APs are set, you have wide scale coverage, everything looks fine, meaning you get signal and connect, et cetera. But that's really in stark contrast to Lync performance and upper layer application performance and the QoE that the user is getting from doing a Lync call, okay? So overall here, just having the coverage is not necessarily indicative of ensuring a good QoE experience. And these are some of the types of conclusions we can draw from doing a baseline assessment. In terms of the networks we come across and how we baseline test today, really two different sides of the house, WAN and Wi-Fi assess, okay? What you're going to see are the different components and how they interact in a Wi-Fi architecture. For example, if you're doing a Lync session on a tablet or smartphone, locally from the Wi-Fi perspective, hitting your AP and a controller, but it's still contained, we cover that type of use case scenario. And what's really interesting is that we're not doing this strictly with synthetic clients. We can actually take your environment's clients and use them as part of the testing. So it gives you an excellent glimpse of that ecosystem. And conversely, if you're traversing across multiple geographical regions or data centers, now you're going up and across your WAN and back down. That all impacts not only obviously your WAN infrastructure, but your localized Wi-Fi infrastructure as well. So our assessment models cover both, as you can see by the nicely laid out flowing lines there. And as we stress those, it gives you really a good glimpse of how your network is behaving, making sure that your internal policies and everything up to par, and really covers a lot of the subject matter that Pascal and Sasha covered. So in terms of WAN, again, what we're doing is we're taking the same type of localized Wi-Fi assessment, but we're branching that out to go across large geographical areas. But it's the same testing concept is used in how we generate that load and the types of metrics that we pull. And really what we do is, in terms of the methodology of these assessments is it's broken out into three main areas. Scalability, so the number of systems, determine the system's ability to support a specific number of clients while maintaining an acceptable link performance. Stability, long term. So what we do is we actually don't just take a pinpoint snapshot in time. We'll actually go ahead and model and do some load testing over a period of time to cover different scenarios under peak load conditions, et cetera. And then, of course, coverage. Coverage from both an RF standpoint, physical locations, and also how the particular devices are impacted, whether that be your tablet or your smartphone. We will incorporate those into the assessment testing. The steps that we go through to perform some of these network readiness assessments always start off with a discovery phase. It's important to understand what the ecosystem looks like before you get started. We then go ahead and spend some time doing traffic profiling modeling. So we build a very accurate load that's indicative of what you're going to have across your network. And then we go ahead and use our tool sets to generate the traffic. We simulate that load and really tweak and adjust it to accurately stress the local environment. And then at the end, we generate a report. What the report will consist of is not just here's how it performed, but also some conclusions and some recommendations, really to kind of steer you in the right direction on what changes need to be made. Some examples can be APs can't support the QoS at the targeted scale, and then some recommendations on how to perhaps adjust that, whether it's enable QoS, upgrade the AP, et cetera. Same thing in terms of a degraded link experience during peak hours. Well, that's one of the findings we come across, so introduce QoS, add another AP. Roaming. Roaming tends to be a hot topic and a big issue. So what we can do is change client devices perhaps, or make modifications to some of the IT policies of those client devices, and also disable ARM and things of that nature. The reason why I have this up here is to show that it's not simply a benchmark to point out issues. It's also then take you to next steps on what to adjust and what to fix. So it's definitely a step above just coverage, but really optimization. And then some of the next steps, again, problem areas, scalability. Using Lync without network changes, you're going to have some scale issues, how many users over Lync that AP can support, and then some of the follow-on services that can be done as a remedy, such as reconfiguring the network. Same thing as with stability. You have to address stability. You don't want your call quality, video quality, et cetera, to suffer. So some of the things that can be done, whether it's upgrading network components, reconfiguring the clients, or changing the clients, again, via IT policy. And last, you'll see their coverage, the limit of usable coverage. Well, how can that be addressed? Whether it's, again, reconfiguring clients, maybe change the AP placement, if there's co-channel interference, things of that nature. These all come out during the benchmark assessment service. Now, whether it's for the end user, or the IT user, or a partner, we offer programs in place to even partner with integrators that can offer this as a service to the end IT user as well. So in terms of the assessment engagement process, if there are any questions or this is something you would be interested in understanding more about to thoroughly get a glimpse of how your infrastructure performs today, this can be pre-deployment, it can be post-deployment for Lync. Definitely feel free to go ahead and contact us at the address you see there. And well, again, even if it's something where you're an integrator and you would like to perhaps introduce this into a service portfolio, by all means, we do work with partners as well, so reach out and let us know. the different phases in summary: discovery, the traffic modeling, the traffic simulation, and then the report. We'll draw it all into conclusion. And these are the main pillars that consist of the network assessment. And this goes for either Wi-Fi or WAN. And then last, to touch upon one of the programs that Pascal had brought up, if you have questions about the APs and soon the client devices, feel free to either yourself reach out to us or talk to your integrator or solution provider to validate if your APs are indeed qualified for the Lync program. You can verify that on the website, and if not, feel free to have them contact us, and we can set them up with our qualification program for APs. And I'd say within probably mid-March, we'll open the doors and go live with the client device qualification program as well.
Yeah, I'd like to add that also, if you guys do have, and you're working with device vendors, like you buy certain Dell or HP, ask them, tell them about this, say, hey, you'd like them to join this device side. And you see on the AP side, if you see your vendors and they're not listed, get them to join the program because it's going to benefit you. And it's not that expensive to do, and it'll really test it for you guys.
Right, exactly. And actually, one other point to the MSIT rollout, that the solution sets and the assessment model that I discussed, a lot of that was leveraged during the MSIT 11N rollout as well.
Yeah, exactly.
So, okay, and with that said, yeah.
Okay, with that,
That's a quick question.
Sure.
Sure. You know, we probably have some interest in looking at overall assessment, but can you help us, like, we're having some specific problems with the Wi-Fi right now.
Right, okay.
Do you guys come in and help us with that kind of stuff? We do the total assessment.
No, definitely we are a global company, so in terms of remote reach, not a problem, and we can come in and help with a specific issue. Obviously, we want to highlight the focus of the Lync readiness assessment, but even aside from that, sure, we can hone in on a certain area.
And so we're worried about the very large
Right.
thing we have, but right now, even on our small system, we're having trouble, so management
Definitely.
say, how the heck is, how are you going to do that?
Right. Yeah, of course, we can also look outside the terms of the assessment, most definitely, yes.
so we are running a bit out of time. Thank you all for coming today to join us for this session. If you have any questions, we will be around. We are all,
Definitely.
Ixia has a stand. We'll be around in Microsoft Pavilion. We'll be around after this session, shortly after, but we have to allow other speakers. Reminder of the party tonight. Hopefully you'll have fun. Hands-on labs, including LRS. And please submit evals. Give us a feedback. We want that. Thank you so much.
Yep, thank you.